Discuss about the design of the beam. Basically, we discussed today the reinforcement specification in beam design. So this specification for the beam design are according to IS 456 2000, in which clause number 26.5.1 describe all this specification. So first of all, we know that beams are provided with main reinforcement on tension side for flexure and transverse reinforcement for shear and torsion. So beam is provided with two reinforcement, basically one main reinforcement for tension side for flexure and transverse reinforcement for shear and torsion. Now first, tension reinforcement. Maximum area of tension reinforcement shall not be less than by this formula. So tension reinforcement area can be calculated by this formula. A is equal to 0.85 BD by Fy, where B is the breadth of the beam or wave of the flange section. Suppose this is a flange section, then each wave. This is wave and B is the breadth of this wave section and D is the effective depth. Fy characteristic strength of reinforced section, and it is expressed in terms of Newton per mm square. This is the minimum area. Now come to maximum area. Maximum area of this tension reinforcement should not exceed 0.04 B into D, where B is the breadth of the section and capital D is the overall depth of the member. So for tension reinforcement, maximum area of the tension reinforcement can be calculated by this formula, and minimum area of the tension reinforcement is calculated by this formula, and maximum area of the tension reinforcement shall not exceed this value. Now coming to compression reinforcement. For compression reinforcement, maximum area should not exceed 0.04 BD, where B is the width of the member and D is the overall depth. And compression reinforcement in beams should be enclosed by stirrups so that it provide effective lateral restraint. Then coming to side reinforcement. When the depth of the wave or rib in the beam exceeds 750 mm, then side reinforcement is provided, and this side reinforcement have area which is not less than 0.1% of the wave area. So for side reinforcement, depth should be exceeds 750 mm, and side reinforcement have cross-sectional area less than 0.1% of the wave area, and this side reinforcement provided equally in both sides of the beam. And spacing of the bars shall not exceed smaller of this value, that means 300, and wave thickness, whichever is less. 300 and wave thickness, the smaller of two values. So now transverse reinforcement or shear reinforcement. For shear reinforcement, maximum or nominal area for the shear reinforcement in the form of stirrup should not exceed this value, that means 0.4 BSB by 0.87 Fy, where ASB is total cross-sectional area of the stirrup legs in shear, and SB spacing of the stirrups along the length of the member. So it is a spacing of stirrups. And Fy is the characteristic strength of the stirrup reinforcement. And it should not exceed 415 Newton per mm square. And B is the width of the beam or wave in the flange section beam. So we calculate minimum or nominal area for shear reinforcement by this formula. Again, maximum spacing. There are two conditions for maximum spacing. If the stirrups are vertical, then maximum spacing should not exceed 0.75 D. And another case is if the stirrups are inclined at 45 degree, then maximum spacing should not exceed D. That means effective depth. Again, maximum spacing is restricted to 300 mm. So for calculating maximum spacing, we can calculate the maximum spacing by considering these conditions. Thank you guys for watching this.